So, as promised, assignment 2 is up. I'm going to write. So your aim is to make a game more or less like the old 80s missile command game. Yes. Front lights down. Which one would that be? No. What happens if I do this light? Nope. Off. Off. Dim down. Ooh, mood lighting. Alright, is that any better? No, what? How do I control these lights? Should be lights off for that. Maybe there's a... No. Sheesh, you think you'd... I can't see anything on this. Hey, alright, well that turned everything off. It's probably not what we wanted. No? What the? Oh, okay. Forward lights off. How do I turn off these lights? Anybody? Anyone? Ooh. No idea. Sorry. No. I can't see anything on here that is... Looks like I either turn off all the lights in the place or I turn off... Oh, we'll press that button for the time being. Yeah, that turns off... Why turn off your lights and not my lights? Oh well. Unless there's something else that I can do to turn these lights off. No. You think it would be easy? No idea. Sorry, that's as good as it gets. So anyway, I'm sure you can. Is there a video of? You can probably find a YouTube video of missile command. It doesn't have to be particularly missile command, and that will do. What does that look like? Ooh, it's back in the good old days when computer games were very blocky. Ooh, and you can't see a bit of it, can you? No, still can't see it. Anyway, there are things falling from the sky, and you are launching things from the, and it has really cool sound effects. Wow, listen to that. Okay, so the basic, all I'm interested in is that there are things falling from the sky. What those things are is up to you. We have a base here at the bottom, and by using the mouse you'll click on things up in the sky which will launch a missile from your base and blow up the thing that you click on. That's the basic behavior I want. You can make it look as pretty or as ugly or as whatever you want. I don't really care. You don't need to implement scoring. You don't need to implement like having lives and such like that. All I'm interested in is your ability to have things falling from the sky, click on them and blow them up. So if we go back to wherever we came from, not that one, not that one, no, that one, yes. So, put your lights back on again. Yeah. Stupid. Anyway. No. Anyway, so again, what you're going to be doing is there are sort of the components I want. I want you to be using prefabs to represent the enemies and the missiles. I want you to then do in-code instantiation and destruction, like we talked about last week, for creating enemies and creating missiles and destroying them at appropriate times. I want you to be using the mouse handlers like we did in this week's tute, and I'll talk a bit more about today, in order to handle clicking on enemies and then collision handlers, which we'll talk about today, in order to work out when your missile hits your enemy and then making them blow up in order appropriately. So that, as long as you've got that kind of behaviour and you're using the objective is to test your ability to use those components more than anything else. So those are the things we'll be looking for. You'll get full marks for that. So the deliverables are, again, we've got a storyboard which you will review in your week 7 tute, and then we'll hand in again in the next week. The JavaScript for all your scripts, and we'll stick a web version for your game. And a number of people have asked me questions about trying to get the web version of their game up for assignment 1. That I realise it's only, a lot of people are talking about using something called Fugu, which I've never even heard of, so I have no idea how to help you there. But it's all right, if you stick it on the web in this week's class, that will be fine. And if you need help to do that, and if we can work out a way of allowing you to do it remotely, I will, but it'll take a bit of messing around. But you should be able to do it all right from the lab, from this week's lab, so that'll be fine. So the same will apply. You put the final version of your game up in the lab after the deadline. But the main thing that we're interested in is getting from you is the storyboard and then the actual scripts that you wrote. The marking is more or less the same as last assignment. 25% on your storyboard design, 25% on your code style, and 50% on the correctness of your code. And I'm breaking that down into 3 components. 20% for getting the falling enemies working right, 15% for the mouse clicking and launching missiles, and 15% for handling the collisions and explosions when you hit something. So I advise you to work incrementally in that order. So if all you can prototype is the falling enemies, if you do a good job of it, or you should still be able to get 70% of the mark for the assignment. So rather than try to get each of those components working before you move on to the next, rather than write one big thing that doesn't do anything very well. And again, the assignment's worth 10% of your mark, and submission instructions will follow. I think I haven't put up the due date. The assignment will be due, I don't know, when did I say? I said in the course outline when this one would be due. Assignment 2, due on Sunday of week 8, so September 19. And there'll be Reza will stick up submission details for that. And on the topic of assignment 1, some people are having difficulty submitting. If you are having problems, please let Reza know. The best way is to send to, well, actually, the best way is to send to CS1400 at CSE. If you send to UNSW, if you send to that address, then it goes to both Reza and I, and whoever of us is able will handle it. Yes?
I noticed that on the previous screen it said you were working pairs. Do you work in pairs?
Oh yeah, this one.
Optional, or?
Yes, this one will be a pairs. I had forgotten about that. Yes, this one will be a pairs exercise. Sorry, I forgot to write that in there. I'll stick that up afterwards. On the issue of sending emails and stuff, blog comments are the worst place to send anything because they generally don't make it to us until it's far too late. Sending a message to the forum is generally the best way because then the answer can go out to everybody. If you want to send a message privately, send it to that address because that'll go to Reza and I and whoever's responsible for that part of the problem. So if it's about submission, Reza will probably handle it. If it's about questions about how to do or like what's in the content of the assignment, I'll handle it. But the forum's generally better for all of that because then the answers will get shared with everybody. Remember also that I don't just teach this subject, so if you send me a message saying I don't understand assignment 1 or I'm having trouble submitting assignment 1, I'll have to go assignment 1 for which subject. And I had two subjects which both had assignment 1 due this weekend, and so it got rather confusing when I got lots of emails from different people saying I'm having trouble with assignment 1. So yeah, please remember to send from your CSE address. We can't do official communication to your butterflyangel@hotmail.com as much as well, whatever. Anyway, as much as we'd like to send your marks out to any miscellaneous person on the web. Yes, so official email through your UNSW email address, and remember to always include your student number in your questions. Otherwise, any other question? Anybody having any particular issues? Hasn't managed to get assignment 1 to submit other than the web version? Has anyone got the JavaScript? Who's managed to submit their JavaScript? Yes? No complaints? That's good. Okay. Yes. Cool. All right. I can't think of anything. Have we got any other admin stuff that we need to cover, Reza? All right. Okay. Cool. Well, then we'll move on to talking about today's lecture. And we'll go back up to here, and we'll play. So we talked a little bit about collisions in the last lecture. I'm going to go back over the stuff we talked about in collisions, and then we'll go on to how to handle objects colliding with each other in our asteroids game. And this is what you're going to need to do in your assignment 2 in order to handle shooting things in that assignment. So this is going to be important. Okay. So we said that in our game we had to have our bullets disappear when they hit something. We had to have our asteroids break up when they are hit. So this is what we're trying to achieve next. Now, so there are 2 components that you need to handle collision checking in Unity. The first one is a collider, and a collider describes the space in which an object exists. So it says a physical object. The mesh is the way the component will look. So every object has a mesh associated with it, which shows you what it looks like. But that mesh is not the same as the collider. The collider tells you how much space does it occupy. And in particular, the big difference is that meshes are usually much more detailed than colliders, because checking collisions on a detailed mesh is really expensive and takes lots of time. So the collider will tell you basically for any point in space, whether it's inside or outside your object, to some degree of approximation. The rigid body is then another component which handles physics on objects, and in particular it handles response to collisions. So we're going to have a look at a little bit of that. If you go to this web page, it has a fairly long description of all the different components that are involved in collisions and physics and such like. Not all of that's going to be relevant to what we're talking about at the moment. So I said before that a collider is the physical volume of an object, and that because we have the option of using a mesh collider, which uses the actual mesh in order to work out whether a point is inside or outside. But if you imagine a really detailed mesh of a human body for your avatar, you don't need to work out every single wrinkle in the face to work out whether a point is inside or outside. You basically just put a large volume around it and say any point that's sufficiently close to that volume is inside. So we've got several different kinds available. The box, sphere, and capsule, and all they do is say, well, rather than, ooh, the board's running away on me. Stay, no, okay. That's freaky. Okay. Obviously not meant to. No. Down. Right, I'm going to put the board all the way down here. That is great. So it's like a moving target. Okay, so if we have our person there, we could check, and that's our mesh. We could check every single point in there. So we give our person a little bit of volume. So this is our person. We could use that mesh in order to work out, and then for every single point we'd have to check whether it's inside or outside that mesh. But that's the more complicated that mesh is, the harder that operation is. So what we usually do is say, okay, we're going to make some approximation to that, and the approximations that we have on hand are either a box, so we can draw a box around the object, or similarly we could have drawn a cylinder. Sorry, not a cylinder, a capsule, which is like a cylinder with rounded ends, or we could draw a sphere for something that's appropriate shaped for a sphere. And sometimes, like this, will make the box big enough for the whole objects inside. Sometimes we might not worry about parts of the object. So if we have a person like this, you know, we might not think that any collisions on the arms are really important, so we might make the box look like that. So now any point within that box is considered a collision with that object. This is important, and any collision on these bits that stick out of the box is just ignored. So generally you'll probably want to use, well, you use whatever fits your object best. That's just, yeah, but so if you've got a long thin object, then a box or a capsule up there, the camera's got it. And if you've got a sort of a more roundish object, then you'll use a sphere. It really depends. There are a couple of other types of colliders as well, but they're not really very important. There's a wheel one for cylinders, which you'll use if you do wheels on your car. The other option also is to have actually have several colliders. So again, we might have if we have the body like this, we might actually represent it by a sphere collider there and a box collider there, and you know, and a capsule there and a capsule there and a capsule there and a capsule there if we wanted to. That's getting a little bit more complicated, but it would give us a closer approximation to this. It still wouldn't take into all the detail of, you know, where the hands and the details of the head were, but at least we'd be able to tell. It would give us some information about where a shot, if we were in an FPS and we wanted to model where on the body we actually got hit, we could have multiple colliders on separate parts of the body which gave us that information. We're not going to go that far. All we're going to do is just use a single box or sphere or cylinder or capsule collider. And you'll find that so they're much cheaper than using mesh colliders. You'll find that the built-in objects in Unity, so if we go down and look at our Unity scene, wherever we were, this scene, I think we were at, what have we got in here? I've forgotten where we were up to. Oh, what's that? Oh, we've got a bug in our code. Where is that? Create asteroid. Okay, we'll get to that later. Oh, okay, whatever. Let's drag that over there. Come back. If we look at our asteroids that we have in our scene, our asteroids, because we just made our asteroids as spheres, they automatically come, zoom in over there, they automatically come with a sphere collider attached to them. So that's not a problem at all. If we created a cube or a capsule, they would automatically come with appropriate shaped colliders on them. If you bring an object from TurboSquid or elsewhere, or Maya or anything you make, you'll have to stick a collider on it in order to work with it. Let's go back to scene one. So there we go. Okay, so what I've done here, just to illustrate this, is our asteroids. I've added a script to the asteroid. Where was it? Not that one. Here's our asteroids prefab. I've added this script here, the change color script. And it takes two colors, one for when the asteroid is being touched and one for when it is no longer being touched. And so if we go and have a look at that script, well, we'll talk about that more in detail at the moment. But what it does is when the mouse is within the volume defined by the collider, the object will change color. So if I bring the mouse over this asteroid, it now changes to green. If I remove the mouse, it now changes to red. If I bring the mouse over this asteroid, it goes green and goes red. So we could change the collider if we wanted to. For example, if we came here and changed the radius of the collider to be much bigger, say 1 rather than 1/2, now if I bring it anywhere close to an asteroid, it automatically changes. So the collider has no relationship to the mesh. This collider is now a bigger space around that asteroid. And if I wanted to you could play with this. If I wanted to assign different colliders to there, you could see the difference in the shape. So if I gave it a box collider, you'd see that it would collide if I was in the rectangle. If I gave it a capsule collider, it would collide within the capsule. So what I've said here was that, about that, any object with a collider will start creating mouse events. So there are 6 different kinds of mouse events that are defined. When the mouse enters the collider, when the mouse exits the collider, as this event on mouse over happens on every single frame as long as the mouse is over the collider. So mouse enter and mouse exit generally only happen once for each time you touch an object. Mouse over happens again and again and again as long as you're touching an object, and then when you stop touching it stops having that event. In the same way, mouse down happens when you press the mouse button, mouse up happens when you release the mouse button, and mouse drag happens on every single frame as long as you've got the mouse down on the object. So these are useful events. In your assignment, you'll be probably wanting to use the mouse down event to tell when you click on an object, and then do something when you click on an object. You might, if you're interested, you might also want to add other events to make it do things like maybe it changes color when you're targeting on something, in which case you might want to have a mouse enter and mouse exit events and stuff, but that's really optional. Mostly what you'll be wanting to use is mouse down, or maybe mouse up. When do you fire when you press the mouse or release the mouse? I think you fire when you press the mouse, so it should be a mouse down event. So I can show you that in that code. Let's go back down to here. So the code we had there was two events, one on mouse enter and one on mouse exit. And I won't bother explaining exactly how this code works, but we grabbed the mesh renderer. So we used get component to grab the mesh renderer component on the asteroid, and we changed its color. Basically, all that means is if we look here in the mesh renderer, there's a materials box, and each material has a color field. We changed that color. Now, there's a little bit going on there that I won't explain right now, but basically that's all we did, was just change that color field to a different value. Let's remove that script now because it's not important. Click, remove. And let's get on to actually handling real collisions. So what we need to know about in order to handle collisions is having rigid bodies on our object. If we just have a collider on an object, it enables Unity to detect when things collide with that object, but it doesn't create any events out of that. So there's no way to actually respond to that. It creates mouse events when the mouse clicks on them, but it doesn't create any events when two things with colliders hit each other. And that's what they're called. So they're called static colliders. So they're basically, if you just have an object in your scenery and you don't want anything to happen to it when it gets hit, but you want other things to respond when they hit it, then you want a collider on it. So if you've got a building, the building doesn't do anything when you hit it, but you might change your direction, or you might explode, or you might, whatever happens when you hit the building. So to detect whether two objects hit each other, they both have to have colliders. But one of them can be static, but one of them has to have some way of responding to that collision. And a static collider isn't enough to do any response. It'll detect the fact that they hit, but it doesn't do anything when they do, which is kind of useless. In order to make something that actually responds to a collision, you need to have a rigid body as well. Anything that has a rigid body on it will start causing events whenever it collides with something. So the rigid body is there to handle collision response. The rigid body also provides built-in physics, but we're not going to be using that right now. So in order to turn off physics, there's an is kinematic option in the rigid body. So let's have a look at that. We come down to our asteroid prefab. We can just hide all this business for the moment. Hide. Oops, no, hide. You can hide that as well. Okay, we can add a rigid body. So we go to component, rigid body is here under physics, and there we go, we've now got a rigid body. Now if we just play that, whoa, okay, so you see that the built-in physics is now working. First of all, there's built-in graphics, so everything's accelerating downwards. Secondly, they're actually responding to collisions with one another, which you can't see very well because they're all moving so fast. But you noticed how at the very beginning when there's a bit of a kick. Ooh, look at that. So the reason they're getting faster is that we're just teleporting them up to the top of the screen. We're not changing their velocity, and so they keep moving. So we can actually make quite complicated physics sims in Unity just by sticking on the rigid body, and then it automatically handles physics for us. We might talk about how to do that a little bit later. Right now we're going to turn the physics off, and we can do that by selecting is kinematic. So there's in the inspector under rigid body there's the kinematic button. And now if we go back and play our game again, there the physics no longer applies, and nothing will actually happen, I don't think. Oops, oh, what's the, oh, I've got to fix that. I think I've changed the bullet speed somewhere. There we go. So it doesn't actually do anything, but they're now, those events are being created, but nothing's happening because we haven't got any handler in there to handle what happens when we collide with things. So now what we need to do is work out, let's fix that bullet first of all. Let's just, actually what I'll do, where's my ship? There's my ship. I had a fire bullet. I'm going to just change to bullet 1. Actually, I don't know where the bullet 1 works. Oh, that's curious. Oh, I've set 0 nozzle velocity. Okay. Let's try that. That's a bit boring. Let's try a bit bigger. It's still slow. Oh, okay. Oh, I'm sending my bullets in the wrong direction. 0 must be. Yeah. That's better. That's much better. Okay, so we're still not actually responding to any events when we collide with things. Actually, a bit faster than that would be nice. 20. Okay, so now what we need to do now is actually work out what to do when a collision occurs. So if we go over to our asteroid, so I have here a script called asteroid collision handler. Actually, let's look at the bullet collision handler first, because that's more interesting. Bullet, if we have a look at bullet move, here we go. So this is the code that you saw earlier that I commented out. So when a collision occurs, this on trigger enter is the event handler for that. And unlike our other event handlers, this one actually has an argument in here. It has a collision as the argument. That's the collider of the other object. So if a bullet collides with an asteroid, then what I get here, this is the bullet. This is the script on the bullet. So that collider will give us the collider on the asteroid. So if we take that collider, it has a game object field which points back to the game object that it's attached to. We can print out that game object's name. So if we put that script on our bullet and run, now whenever we shoot something, okay, you'll see down the bottom of the screen, it's a bit hard to read, but it's actually printing out, oh, that's an issue. What's it doing? Oh, okay. You're down the bottom of the screen here, which you can't see, but it's printing out down here the name of the object that it collided with. Now, right now, we've got a bit of a problem because the name of the object that it collided with is the ship. So it's actually saying to me that the bullet is colliding with the ship, and that's happening because I've got a collider on the ship. We can actually just remove that collider from the ship for the time being. So we take the ship and we can remove its collider. We won't worry about that right now. There we go, that's better. Now our bullets fire, and our bullets now stop when they hit an asteroid. Oh, and they're stopping outside the asteroid because we made that collider bigger. So let's go back to this collider and change it back to 1/2, which is where it was originally. Right, that's better. Now when our bullets hit an asteroid, they stop. And the reason why they stop is because in our on-trigger enter, first of all we print out the name and then we destroy game object, which is the bullet. So the bullet, when it hits something, the bullet destroys itself, and that's the right thing for it to do. So that's doing what we want. In this case, we don't actually need to know what the thing we're colliding with, because the bullet always destroys itself whenever it collides with anything. So that's happy. But in some cases, we obviously need to do what we need to do depends on what happens when we collide. Now, at the other end, what we could do in here is we could write code in here to destroy the asteroids, so that when we hit an asteroid, the asteroid is also destroyed. But it actually makes more sense for that event, because that event deals with the asteroid. That code should go on the asteroid script rather than on the bullet script. So we won't destroy the asteroid in there because that's kind of the wrong place for it. What we'll do instead is add an asteroid collision handler, and I'm going to write, rather than use that script, which is rather long, I'm going to write a new one. Handler, something like that, handler. Okay, so open that. The collision handler doesn't have an update method, we don't need one, but it needs an on trigger enter, and we take, we'll call that other. Now the easiest thing to do here would be we could just say game object dot destroy. Destroy. I think that's the right. Is that right? I think that's right. What did we have on the bullet? No, sorry, it's destroy game object. I got that around the wrong way. So that's not. Oops. Destroy game object. Right, so now when an asteroid gets hit by a bullet, it destroys itself. Now let's add that handler to our prefab. Oh, can't do that directly, got to open the prefab, add the collision handler, stick that not there, down there, go away, go away. Now, when I fire bullets, hey, our asteroids destroy. The problem is that some of our asteroids are bumping into other asteroids. Actually, some of our asteroids aren't bumping into. That's weird. Why are our asteroids not bumping into each other? That's curious. Oh, I know why our asteroids aren't. No, I don't know why our asteroids aren't destroying each other. Why are asteroids? That's weird. I would have expected at this point that our asteroids would be killing each other when they bump into each other, but they're not. And I don't really know why. That's a good question. So we've got our bullet 1. So our bullets also have a rigid body now because I changed to a bullet that has. That's weird. Why are our asteroids not just dying when they bump into each other? They have rigid bodies. I don't know. That is weird. Let me just try something. Print other dot game object dot name. So our asteroids should be bumping into each other, and they're not. That's weird. Let's wait for these two to collide. And go figure. I don't know why that's happening. There you go. So I have to, anyway, that's really strange because... Yeah, they're kinematic, that's fine. They should be...
Well, the asteroids are on the same plane.
Yeah, well, they should all be on the same plane. Let's have a look. See, this is debugging in action. Yes, they're all... Yep. They are actually bumping into one another. They're just not. I have no idea. I'll have to go off and look into that because I don't know why they're not bumping into each other. Anyway, in the meantime, so if we go back and add a we'll go back and add a collider to our we'll add a capsule collider to our ship. Now it should also, if we, oh, that's not handling either. Why is that not handling? Okay, that's weird. We haven't got a rigid body on there. Let's add a rigid body to the ship as well. Let's make the rigid body kinematic. Why is that not causing cliff? I am now completely at a loss to explain why this isn't clear. That's weird. So, asteroids, collision handler, on trigger enter. I don't know. That's really strange. Anyway, this worked before the show, I promise. Anyway, I'll move on. So, again, again, just to highlight, so we're causing a trigger enter event, which again causes that method in the scripts to run. It takes a collider as a parameter, and if you have a look here, in fact, just like the mouse events, there's not only the trigger enter event, there's also a couple of others. There's trigger, there it is. So there's trigger enter, trigger exit, and trigger stay. And so trigger enter happens when the objects collide. Trigger exit when the collision has stopped, when they stop touching one another. And trigger stay is called once per frame as long as they're overlapping. So again, like the mouse events, there's one when it starts, one when it stops, and one that happens on every frame as long as it's true. And which one you want to do is up to you. Back to Keynote, wherever it's gone. So the code that we might do look something like that. That whenever we collide with something, we'll print out the name of the thing we hit. And that's a useful bit of debugging code, at least, in order for you to work out what's going on when you've got things colliding in places, in ways that you don't want them to, or as in our case, not colliding when we're expecting them to collide. Now, if this was doing what I would expect it to do, we would have problems with objects colliding with more than just the bullets colliding with the asteroids. We'd also have asteroids colliding with other asteroids and asteroids colliding with the player. And I'm not quite sure why that's not happening, but that would normally be an issue. I'm going to have to look into that. We need to actually, in order to work out what to do in those cases, we need to have some way of checking what the object that we've collided with is and handle the response appropriately. So one way of doing that is through tagging. And tagging is a way of tagging a whole bunch of separate objects with the same tag so that we know what kind of thing they are. So it's just for identifying. So we'll give one tag to all the asteroids, one tag to all the bullets, and a separate tag to the ship. And then we can check tags in order to see what something is when we collide with it. So we create tags by using the tag manager. We can either say look in the edit menu, or we can use add tag in the inspector. And again, we use the inspector to add a tag to something. So if we come down to our asteroid, I'm going to actually change, here, we look at our asteroid. So we can either go edit, project settings, tags, or alternatively we can just open up the tag manager by clicking here, clicking add tag. Both of them bring up this tag manager like this. And you see that if we can zoom in on that, we can see that I've defined a couple of different tags here. And you can just define, in fact, I don't know why there's that tag. Let's get rid of that tag. I actually was going to add a shield to the game as well. I haven't got that far yet. But there are separate tags for the ship, the bullets, the asteroids, and you can make as many of these as you want. You know, you can just say foo bar as, etc. And every time you add a new one, it just adds one more to the list. I don't know what the upper limit is. It's probably something huge, but you know, generally having a couple of different tags is useful. Then, in order to check tags, what we do in here, if this was doing what I expected to do, we'd actually want to check what kind of object we'd collided with. And I've forgotten the code for that, so we'll go on. The code for that is compare tag. So every game object has a compare tag method that looks at the tag of the object and checks whether it's equal to some string. So for example, if we wanted to tell, if all our bullets were tagged with bullet, and we were on an asteroid and we wanted to check whether the asteroid had collided with a bullet, we could check, use compare tag like this. It returns a Boolean, so we can put it in an if statement. And this condition will be true if the object is tagged with bullet, and therefore it'll do whatever we need to do when we're hit by a bullet. We could then have separate cases for if two asteroids collide, or if an asteroid collides with a ship, what's supposed to happen. And that's as far as I got there. So let's actually change over to a slightly more complicated scene. We'll look at this scene. Actually, no, what we'll do, rather than that, I'll just change the prefab. I've got here's one I prepared earlier, asteroid prefab. So this asteroid prefab has a more complicated collision handler script on it, which hopefully, yep, there we go. When we actually shoot an asteroid now, it splits into smaller asteroids. And we run, oops, nothing happens when we run the ship through it. Okay, so we'll have a look at the code about how we did that. So this is the code for handling that collision. Again, we, oops, actually that's not the easiest way to do it. So we have a variable to keep track of how many times we split, because we only want to allow it to split like 3 times before we just destroy the thing, so we keep that track of it. This is our maximum number of splits. We can split up to 2 times. If we split more than 2 times, then we destroy the asteroid. And this is how many children we create when we destroy an asteroid. And now see here we're using compare tag. If we've collided with another asteroid, we do nothing. If we've collided with the ship, again, we do nothing in this case. Later on, we might want to do something appropriate there. I don't know what happens to an asteroid. Does an asteroid split when it hits the ship? Maybe it should. But if we've hit a bullet, now we need to split the object. So the first thing we do is check how many times we split it. So each asteroid keeps track of how many times it's been split. So we add 1 to that number of times and check whether or not it's greater than the maximum number of times that we're allowed to split. If we've exceeded the number of times we're allowed to split, then we just destroy the asteroid. Otherwise, we come further down. Otherwise, we use the local scale on the transform, which is the way of scaling objects. And this time we divide it by 1.5, which is a magic number, which I really should give should assign to a variable rather than leave there as a magic number. But this is shrinking the asteroid down. So the asteroid will be 2/3 the size it was before. I don't quite know why I said divided by 1.5. That seems a silly way of doing it. Anyway, so the asteroid is now 2/3 its previous size. Now we need to make some copies. Now, I showed you before how you could use instantiate to instantiate a prefab, but you can instantiate any existing game object, which just creates a clone of that game object. So in this case, we've already got the asteroid there in the world. It's got all its data associated with it that we want, and even its position is correct. We just want to make a clone of it. So we use instantiate to create a new version of it. We then also, I don't know whether this is actually necessary. It's possibly not necessary to set its position. I think it would probably inherit its position from the thing we're cloning. So we could probably remove that line. And we're setting its parent. This might also be inherited. I just wrote this code by automatically. The other thing to note here, though, is that when we instantiate a new object, the start script on that object is called. So any start functions, any things that have start event handlers on them will run on that. So all the children, in particular the asteroids, the asteroid has a start which makes it go in a random direction. So when we clone the object, it automatically the clones automatically start moving off in different directions, which is nice reuse of code. We don't have to write any more code in order to make our asteroids split up and move in different directions. They automatically do that because that's what an asteroid does whenever it's created. So there's a nice thing here. We use a for loop in order to create as many clones as we need. The number of times we go around the for loop is the number of children minus 1. Now the reason it's minus 1 is because we've already got 1 there. So if we need 3 children, we've got 1 asteroid, we just need to create 2 more. And so we use the for loop to run this code twice to create 2 clones and stick them in there as well. And then those clones automatically start moving around in space and doing everything that their parent was doing before we shot it. So that's a really nice, simple way of making making asteroids split up, and gives us the behaviour that we can see here, where when we shoot an asteroid, it splits. Now I'm going to just try and see, out of curiosity, print other game object name, since I've just moved. So this should, yeah, okay, that is working. That's weird. So these asteroids, I'm using a different prefab here, and this prefab, for some reason or other, is responding to those events. So I'm not sure why that one isn't. That's weird. I don't know. Anyway, I'll have to look into that. But yes, so this one's working the way I expected. When it collides, it can collide with other asteroids, and it can also collide with the ship. Now nothing happens because we're checking each of those cases, and we do nothing. If we remove this code, let's see if we can. If we remove those tests, and just save that, then presumably now asteroids, yep, they disappear when they're disappearing because they're colliding, and then all their children are colliding immediately with one another, and so they collide, split, collide, split, collide, split until there's nothing left, which is what we'd expect. So that's what I was expecting to see before, but I don't know why it didn't happen before. Never mind. This is why we always prepare stuff before the show rather than trying to do it on the fly. So that's why we need to check tags in order to see whether or not we've got the right things colliding with one another. In a complicated scene, you might have many different things which can actually collide with each other, only some of which some are collisions you want to pay attention to and some you don't. And so this is sort of the general way to do that. All right, that's enough for today. I'm not sure what we'll be dealing with on Wednesday. I'll have to write the lectures tomorrow. So, yep. Thank you. Any questions? Any insights found? Anyone want to share shoelace tying methods? Okay, cool. Go home. See you later.